everyone. I'm George Mount from the UI Toolkit team, and I'm here to talk to you about Android data binding. Before we started this, I sought some random Android developer out there for some help in this talk, and I'd like to introduce you to, I'm sorry, what was your name?
Random123.
Random123, why don't you come up here? I stole, I hope you don't mind, I had some friends in the NSA. I looked at your laptop and put it up here on the screen. You guys, shh, don't tell anyone.
My code. All right. So I love Android. I love that little green robot. But as a developer, some parts really is terrible. Like, I'm writing so much code, George. It's like, why is this like this? Why all this like all stupid code here?
Yeah.
Why do I need that? Why can't they
find view by ID? I mean,
everywhere? Like this product image, set that, set this. Like,
what?
Did I study computer science for this? I don't think so.
No.
That's what I think.
We gotta have something better than that, right?
Do you have something in the box?
I do. Let's talk about Android data binding, okay? Bling, did you see that? All right. All right, let's look at your code in a little bit of detail. I see this set product UI you're using, calling from onCreate, right? That's just a pain. Let's get rid of it. We don't want that. Instead, let's look at this onCreate. Let's instead just bind your layout to this binding code and then set the product on there and let the binding take care of all the work. Sound good? A little better?
Let's see about that.
Okay.
I'm skeptical.
All right, all right. Let's look at your layout. Wow, you have a lot of ellipses in your layout, man. What's up with that? All right, so to make sure that we understand that it's a data binding layout, first we add this layout tag to the outside, and then we get this variable, the prod variable that we set in the onCreate. All right, and then we can use that prod variable anywhere in our layout. So instead of this ID, we can now access that prod variable. So for example, in the source, it's an image drawable, so we can access it directly. The prod name, the product name, it's a string, and same with the description.
There is a bug, though.
Oh.
There you go. It's
that
not
price?
the price.
Oh, dang.
It's a crash.
Ah, shoot. All right. Well, our price is, well, if you look at the code there, it's a resource, right? And our resource is a string, and it's doing a format. We should do better in our expression, right?
I expect so.
I think so. All right. So one good thing is that now we can access our layout, our expression stuff directly in our layout. So we can have this access to the string resource right there.
Ooh.
And pass a parameter. We're passing the product price as a parameter in our resource, in our layout.
Looks good.
Pretty cool, huh?
OK, so, but in my application, things are not always static, George. I'm cool with your demo. But I have this application where sometimes I have a different layout, right? Like, yes, there you go. It might be on sale. Like, how do I do this? I'm going to need to write more code to do this.
Well, boy, wine. You want everything, don't you? Well, we allow you to, inside your layout, to have some little dynamism in there. You can have an expression that says, if you're on sale, then show this on sale sign. And if you're on sale, you might also have a different color for your
Again, your example is not very realistic because my price changes. It's a very dynamic website. So I do dynamic pricing. How do you handle that?
Well, you have to at least tell us when it changes. So let's look at your product. Your product has a price, a name, and an image. You have to just extend the base observable class, and then we mark the things that you can change, that are going to change, as bindable. And then you have to tell us when it changes. So we have this notify property change. And the bindable part.
But like my classes extend the base class. I cannot extend your class. That is not that good.
Come on. All right. Fine. We can use an observable interface instead. Is that better?
Maybe. Let's see about that.
We'll give you a little bit of help here. We'll give you this property change registry so you can just tell us when that happens, OK? Is that a little better?
Yeah. That's good enough.
All right. That's a little better. So,
anything easier?
Yeah, this is a little easier, huh? It'd be nice if we could just have properties that are themselves observable, isn't it? Wouldn't it be?
Yeah, OK.
Here you can access them as if it was just the same with the same expression. You just say your prod.image, and even though it's not a drawable itself, we pretend that it's a drawable. It's an observable field, and it's an observable double for price. What are you using that
Double
for?
the price, that's the economy, right?
You shouldn't be using double for your prices. All right. Or if you have more blobby data, like let's imagine you're coming in from JSON and you're still doing development, everything's up in the air, you don't know what's going to be like, you can use a map. And that's pretty nice for prototyping.
Yeah, seems interesting. How about multiple layouts?
Multiple layouts. Well, yeah, I guess you have different variables in different layouts.
Activities now?
Yeah, I hope not. Boy, that would be a pain, wouldn't it? Oh, you have multiple. You have like in one you're setting the product, and the other one you're setting the product list. It's really a pain. You don't want to have to do if it's on the landscape, do this, and if you're in portrait, do this. So instead, what we do is we merge all of your variables, and we produce one that has the summation of all the variables that you need. And the binding will just say, oh, I only need these variables, and I'll use those in my layout. The rest of them, I'll just not use at all. You just set it and forget it. It's great. Just like Ronco, right?
Yeah, that seems good. Seems good. Talk about the downsides.
But wait, there's more.
Ooh.
All right. You don't need to do any more find view by ID, right? Because now all your expressions are right there in your layout file.
Yeah, but I do run animations, and you also like, put them into data binding. That seems weird.
Yeah. Well, OK. You still don't need find view by ID. If you have a layout with a view with a tag, an ID in it, then what we do is we automatically extract that view and stick it as a public final field in your binding. So you can access it directly from the binding.
That sounds good.
You really don't need find view by ID anymore.
I don't write that code.
Yeah. That stuff is a pain, isn't it? Also, we have these automatic properties. For example, here's this drawer layout, right? And there's this really nice setter, set scrim color. Wouldn't it be nice to be able to just tag it so you could just set it right there in your layout file? But there's no attribute for that. Well, we could just kind of sneak in and say, oh, set scrim color. That looks a lot like scrim color, right? Just a set right in front of it. So we just look at it and say, set scrim color. And we just say, oh, automatically we just say, OK, if you have this thing with a data binding expression in it, then we will look for the setter with it, where that takes the same type of parameter. So in this case, the color scrim is an int, so we say, oh, set scrim color. We know exactly what it is. It's just automatic for you. You don't have to create this new attribute for yourself. And everyone's favorite, onClick, right? Pretty awesome.
Sure.
But
infamous.
So we have this as well. We can do onClick with expressions. Pretty nice. But
how does it work?
we also have, well, I think we'll talk about that in a little bit.
Right.
Yeah, we also have this, we have all the other event handlers too, like on long click or on item select, whatever, all those things. On text change. On text change is a real interesting one, right? Because it's a text watcher, and there are 3 handlers on there. You can just set 1 of them, 2 of them, 3 of them, whatever you want. It's pretty nice. How much would you pay? What's the performance you would pay for this? 20%?
No, of course not. Okay.
10%?
Maybe.
All right. How about nothing?
Wow, no way.
No.
No way. No. He's lying. All these sellers.
It might not be nothing, depending on how optimal your code is, but it's pretty good. It's pretty good. So I want to bring up my co-conspirator in this. Let me introduce you to Yeet Boyar from.
Hey everybody, I'm Yeet from the UI Toolkit team. We work on data binding with George, and I'm going to go into some details on how it actually works. So as George showed before, the layouts are a little bit different now. You have a layout tag in the root. This tells us this is a data binding layout. And we pass it into the layout grinder, which processes your layouts and then exports a new layout that the older Android versions can understand, which doesn't have the layout tag anymore. We move the namespaces to your first child. And it also has some subproducts from the processing. It creates a class. It creates all these like public final fields for your views with IDs. And it creates the setters for your variables. So to go into detail, this is what actually is happening. We move that namespace to your first child, get rid of the layout tag, and this is done while your application is compiled by Gradle. And then we remove your expressions, add some tags there so we can find those views afterwards. And if you had an ID, we would keep it there and also create the view. As you can see, they're directly matching this public file. You don't need to cast anymore because we know what type it is at compile time, so we just create the variable with that type. Okay. So how do we do this? So one important aspect of data binding is that almost everything is done at compile time. So when we see an expression like this, while your Java code is being compiled, we go check, OK, this product, we know what type it is because you told us. Now we say, OK, product.image. Product has an image field or an image getter. We look for these things, find that, and then, OK, here we found this. There's a drawable returning getImage method. Then we check, OK, I have a drawable. There's a source attribute. Can I set this drawable to this source attribute? And then we call setSource there. The cool part is we don't need any reflection to do any of these things because we do it at compile time. So at runtime is equal to the code that you would write yourself.
Hey, wait a second. I thought all data binding frameworks needed reflection, don't they?
Not the new ones.
Not this one? Oh,
Not this one.
Nice.
So for example, but it's not that trivial, right? That example was simple. So you can say, I have my variable, set it as text. Correct, that's straightforward. You say it's the user.image, the source, I call setSource, which I said before, which does not exist. So this is a problem because the image view doesn't have a setSource method. It has a source attribute, but it's a setImageDrawable method where you can pass a drawable. How does data binding know about this? It's done by annotations. So we have this binding method annotation, where you can say, OK, this is a binding annotation for a type class image view. The attribute is source, and the method is called setImageDrawable, so that we know that attribute source maps to setImageDrawable. If the pass parameters match, we can use that method to run the binding. Again, this is done in the compile time. What we generate is the same code that you will do at setImageDrawable. What the event handler? So these are a little bit tricky because unfortunately Java 7 didn't have any function parameters. You cannot do them. So the way this works is, again, we know there's a binding method that says onClick matches setOnClick listener. And we look at, OK, what does the setOnClick listener expect? Oh, it expects a view.onClick listener. That's an interface, or great. And then the interface has one method. Then we look for that handler.clicked matches that one method. So going in details, we saw this, and then we saw this. OK, nice that the handler.click method receives a view, and this matches. So we create the interface for you so that Java is happy, and then we are going to tunnel those calls to your handler. So you can see everything is matching. It just works. Oops, too fast.
Stealing my thunder here.
All right, binding adapter.
Let's talk about binding adapters. Binding adapters are probably the coolest part about data binding. So let's talk about something a little bit more complicated than setText, right? SetText was a nice automatic variable. You can just set text, it takes in a string, or actually text takes in a char sequence, but it's pretty close. But let's talk about something more interesting. We have this image view, but we have a large URL, like a large image data coming down. And if we do this, what's going to happen, right? We don't want this on the UI thread. It's going to load everything on the UI thread. That's pretty lousy. I don't like that.
Why not?
So instead, I'm going to use a tool. How about Picasso, right? Or Glide? What's your favorite?
I'd rather not say that.
All right. In this example, whoever it was who wrote this expression tried to use Picasso, but my goodness, Picasso with context, load, that's a heck of an expression. And into what do you do? I don't know. That's loud.
You can have an expression language. Why not?
I don't like this. This is just too, we don't want to see that in our expressions anyway. So let's do something a little simpler. Instead, what we're going to do is create a binding adapter. And we're going to use the Android source. We're going to override what the default behavior is with our binding adapter. And instead of doing the normal stuff, we're going to try to do something special. So what we're going to do is set this binding adapter. Of course, this is an attribute, an annotation on our static method here. And it can be any static method anywhere. And we're just going to look for that static method with the attribute, the annotation. And here we're going to look for something that is an image view, and it takes in a string as a parameter. Okay? And now what we can do is do anything we want in that class. So we have this nice Picasso. We can use the context from the view. We can load the image in there, and it can be done all off the UI thread. And it's all kind of magic. Now you can do image source is equal to some value. It's great. But what if you want to do something more interesting? Let's imagine you want to have a placeholder for your annotation. Now, you have to do this with Picasso in the same call, right? You can't just say, in one call, call the load, and the other one you do. So what we're going to do is we're going to merge it all together into one binding adapter. And this one takes two kind of attributes, and they can work together. And you just take the parameters in the order that you've assigned them in the annotation, and now you can do whatever you want in the method. In this case, we're going to load the URL off thread, and in the meantime, we'll load this placeholder image. Now, sometimes you want to have some kind of instance information in your adapter. And before, we were using static methods, right? But what happens if you want to use an instance? Right? With the static method, it's easy. We know what to do. We can call it directly, just myClass.static method call. Very simple to do in your the generated binding class that we have.
How do you get the instance?
So yeah, I mean, we take out the static. What happens? Right, where does that instance come from? We have to do some kind of instance. So what we're going to do is the binding framework is going to look and see, oh, this is an instance binding adapter. We need to generate this method on this class, this data binding component class. And this method is going to be called get, whatever the name of your adapter class is. And now it's your job to implement this method, to implement this class. So you implement this class, and then you call set default component on it. Now there's also ones if you want to load a specific implementation for a specific binding if you want. But most of the time, you probably want just a default component that you're going to load. And then we know exactly what instance we're going to load for your binding adapter. Very nice. Now, you can also do this with components. Now, when you're doing it with a component, if you have some kind of state you want to get, imagine this is a cache for your images, right? So you want to load the image from your cache first, and then possibly load it off thread. In this case, we need to go on what that instance is. We're going to pass it as a static method, use of static method, but we want to have some kind of instance that we're going to share around to all the different binding adapters. So in this case, we need to know what that state is. So in this case, you implement your data binding component, but you add your own method to it. Okay? So when you add your own method to it, we don't know anything about this method. This is something that you know about. But we're going to pass it to you as the first parameter, if you'd like. Now you can do whatever you want. So we have our own cache here that we can load our data from. Let's talk a little about best practices.
Okay, yeah, let's go through some examples.
They say practice makes perfect.
Practice, man. Internal joke, sorry. So let's look at some examples. So data binding allows you to write some expressions in the XML. That means I can just send a web service call from my XML, right? Why not? There's a click listener, there's an API. Why should not I do this? You should not do this. If you do this, your application will break. That's not what data binding is for. Data binding is to put data into your UI from your model. So instead of doing that, have a callback, have a presenter, whatever model you prefer, and just tunnel the call to the Java where you do the real thing. Don't try to do business logic through your XML. It's not going to work. But another example, in a good way, is that I want to change this drawable based on the user's age, or I want to just redact it, in that case, it's fine. Like, it's just what the UI sees is a super simple expression. That's okay, because here's an advantage. When you put this, when I look at this UI, it's okay, I know that if the age is this UI shows this drawable, otherwise the other one. It's very clear. It makes my XML better, my code cleaner, so that's okay. So you need to decide it for yourself. But if you do something like this, where they just small, I do something, otherwise I redact it, like, I don't understand what this code is doing when I look at it, then there's a problem. Like, it doesn't make sense. Instead of doing it, do something more simpler, like if the age is this, put the display name, otherwise redact it, and the display name comes from your model. If your object doesn't really have that field, which doesn't in this case, you create a view model that provides that information, or you can make the variable for your binding layout.
I think you took that from my code. I'm sorry.
It's not very good. Yeah, he got data binding wrong.
Hey.
So you can also do like, so if your view model can dispatch events, in this example, we make this display name bindable, where in return, data binding is going to generate this BR class, similar to the R class, but for bindable things. And when the user's last name is set, you can dispatch that it has changed, and data binding will keep the UI up to date. This is where, like, if you have value objects and you're directly showing them in your UI, that's okay to set them as variables in your layout and then set them in your generated binding class. But if that's not the case, if you need more information, consider using a view model where you put this information there, and you can just use these observable convenience fields we provide in your view models. You just set them, and data binding makes sure of that they are visible on the UI. By the way, observables are not like those convenience observable classes we provide. They're nice if they're very few. If you try to make your value objects with those things, you're just using out of memory for no reason. Don't do that. But they're nice if you have a view model, or you can have them in your activity if there's something you want to easily control. So there's another example where you write a view model extending the base observable class because you don't want to use those convenient classes. The same example here, when the data changes, you notify, and then data binding takes care of this. Or you can implement the observable interface. Then we provide this provide to change registry class, which allows you to dispatch events. All you have to do is just notify property change through that class. And when we then remove callbacks, you just send those calls to this class, and it will take care of it. The other part is like, this is a beautiful example. I know many people has been asking for this font attribute in TextView that we never did. There's some reasons for that. You can ask the Rafe. And someone, Lisa, I don't know if she's here, she created this thing where I can set my fonts in XML. I want to do that. It's much cleaner. And this became very popular. I like this example. Because like the good thing about this example is it makes your XML very clean. You look at it, you understand what it's trying to do. And there's no added performance cost in all of these things. So you write a binding adapter that says, I know how to set a font on a text view. It's all well defined. And in this code, you get the font, you load the typeface, and set it on the text view. And if this was a real application, you would probably cache it so that you don't keep reloading the font. Beautiful. OK, another good example is the image adapter. So I'm using another image loader here, Glide, and where I can say, this adapter knows how to set a photo URL. It might have a default, but they are not required. So that if there's only a photo URL set on that view, we will still call the adapter. The other value will receive a default value, which is if it is an object, it will be null. So integer will be 0, and like all the default values you can imagine. And this way, I can write just one adapter that can handle multiple attribute groups. And if it is an instance method, you can just create this app component that implements the data binding component and just returns your image adapter. This is very nice for testing, so that while the test is running, you can basically just set the default or do nothing, because no one wants to call network during a test unless you are testing the network. So I have this mock version here that I inject during my test, and it just does nothing. Uses the default drawable. And does nothing. So this works one-on-one with the dependency injection very well. Actually, like you can just say inject image adapter, create this app component, and for example, if you're using Dagger 2, this will take care of the rest. You don't need to do anything else. And this is a Dagger 2 implementation where we only say, I mean, we create the model for the stuff, and we say we implement this, and then Dagger generates the rest of the code, assuming that you have a provider. And thank you. Okay.
We were super fast, so we have time for lots of questions.
There are 2 microphones left and right. Please use them to ask questions.
Hi.
Hi.
So my question is about, so when you use data mining, it's not always obvious what's happening in the UX editor, if you understand what I mean. So it would be nice to be able to provide like a default product or something to mock, so I can see what the UX looks like in the editor as well.
Yeah, that was one of the first things that we talked about when we were talking to the Android Studio team, and they were really excited about data binding, but you know, they're working on, as you saw in the last talk, they are working on some pretty exciting things right now, and so they're going to get to it, but they're not there yet.
I mean, well, I can tell the code completion is coming. It's very close, so that's good news for data binding, and that's one of the things we should do.
Thank you.
Okay, let's get one from here.
Is it possible to inflate view stub according to data binding?
You said inflate new stuff?
View stuff.
View stub.
ViewStub, oh yes. Yeah, so ViewStub, there's a special implementation for ViewStub because ViewStub is as you saw, we have final classes, final fields. So we have a ViewStub proxy final field for that because ViewStub actually replaces itself with a view. So we can't do a replacement for a final field, right? So we have a ViewStub proxy, and you can get either the ViewStub or the replaced view with it, depending on its status.
Okay, and it is possible to pass data model to like underlying layout?
Yeah. Yes, you could. So when you create it, you use the same expression as if you are passing an attribute. And if there's a binding for that class, we know to create the binding for that class and pass that variable as the variable changes.
Cool, thank you.
Hello. Current design tab inside Android Studio sometimes doesn't render layout correctly. Yeah, sometimes there is just black screen or something like this. Are you going to improve this, and will it work with data binding also?
So yeah, we're constantly improving the Android Studio layout editor. So that's going to get better and better over time, absolutely.
Okay, thank you.
I was wondering, you showed the image loading examples.
Yes.
How would you go about canceling the loads when your UI is torn down somewhere?
You have the binding, so you can null it. So for example, you create the binding, like what are you trying to cancel? Is the, let's say you were trying to load user image URL and then the image URL disappeared, or?
No, I mean like in Picasso, you can pass a tag and then cancel every loads on those tags, for example, when your fragment goes away or something like that.
You could be, I mean, one option would be passing that tag as well to the binding adapter, and then you can cancel through Picasa. Or if there's some variable in your model that can control that, then again, the binding adapter can handle the canceling.
Okay, but it's no really a callback for tearing down.
You can pass a callback variable if you want. For the views tearing down, no, there is not. I mean, you know when the view is going away through the Android view lifecycle. And there are callback methods that you can assign to this binding class. You can even say, hey, like, stop, don't rebind. I know the data, like, when the data changes, the generated binding class calls your callback. I'm about to rebind. And then you can say, no, don't stop, don't rebind. And when you say that, you are responsible to tell it to rebind whenever you want, which is very useful for if you're using it inside the recycler view. Recycler gets really upset if you update the views themselves directly. So if you're writing recycler view adapter, you say, no, don't change. And then it runs it through the recycler views, like item change flow.
Okay, I think that answers my question.
Got it.
You want to go to this side? Yeah.
Hey, what's the best way to debug the expressions that are in the view markup? Because it's logic, effectively. And so if there's a bug, how do you debug it? How do you step through it?
Well, you can step through the code. The source code that we generate is actually visible to you. It's generated, and you can step through it if you need to.
Oh.
It's a little bit on the uglier side because it's generated code.
Right.
But you can step through it.
Okay.
But you should try to limit what your expressions look like. Now we have some things that make it a lot easier for you, so that you'll have fewer bugs. For example, we have a null coalescent operator, which I don't know if you guys, those of you who've used other languages know what this is, but essentially it says if the first part is null, then use the second part. And we also automatically do null checks on your expressions. So if any part of it is null, then the resultant value is the default value. So if you call setText on user.name, then if user is null, then the whole expression is null. So it's not, you'll see fewer bugs from that. And you should, like in the best practices, you should limit your expressions so they're not too complicated.
Yeah, I would agree. Yeah.
Hello. So when we're doing using data binding with recycle views, actually the documentation says that we should, after getting the view, passing the view to the view holder and get the binding clause, we should use execute pending bindings. I want to know exactly what is it like, because I tried to use on list view and didn't call that method and worked fine.
It will work fine, but it will. So data binding, as the variables change, we don't instantly go and update the views. What data binding does is we just keep track of them and wait until the next animation frame happens. This helps us to run less expressions, becomes more efficient, plus you can change your data on any thread. You don't need to be on the main thread while changing your data, and data binding will take care of moving it to the main thread. Now, the way this works is you wait until the next animation frame. From a recycler view's perspective, or for the list view, what it does is it calls your onBind method, and it expects the view to be updated when that method returns. So if there's any text view that you should have set the text when that happens, otherwise the view won't be measured properly, the first layout will be wrong, the next animation frame data binding will update that view, that's going to cause another layout which will correct itself. So it will look like it worked fine, but you actually did two layouts for no reason. So by calling execute pending bindings, you synchronously sync all the views with your model, so that data binding is not going to request another layout, and the list view or recycler view will run the proper layout calculations.
Cool. So the last one. When we're importing variables such as Android, the view class, the base view class to use an expression, at least I want to know if on the new Android Studio we actually have an error fix, because if you try to do that expression of setting visibility, it actually show you an error even before compiling. So I want to know if that fixed on Android Studio.
You said for compiling? It shouldn't show you errors for compiling.
It does show an error. So a very detailed problem, but while parsing your expressions, we use Antler, which is like grammar parser library, is very popular. But that model doesn't work on IntelliJ. So IntelliJ suggests using another parser called Flex, JFlex. So sometimes these grammars don't match properly. So if you have a bug, just report it and we will try to fix it. We are working on some other solution that will allow us to use Antler parser inside IntelliJ, but there's fundamental different models. So it's not very trivial, but we are working on making it more reliable. Cool. All right. Thank you.